Okay, so this is lesson 3. This is an important concept because after this, we're to combine everything together and actually analyze a full circuit with kind of different series and parallel circuit all together. How would it affect the overall current if I say plugged more things in total, right? So this is the law that's called the Kirchhoff's law. And it mainly has two things that we're going to be talking about. It's mainly going to be talking about the electric potential difference, so the voltage, as well as the current. So there's actually two laws. Okay, the first law is called the Kirchhoff's voltage law. Okay, they're saying that in any complete path, I like to use the word loop. Okay, so I'm just going to write the word loop. So in a loop, what happened is the total potential increase is equal at the source is equals to the total potential decrease at the rest of the circuit. So yesterday we talked about this. So hopefully you can kind of recall it together. We're saying that voltage increase always happen at battery or the source. And then at the same time, if I have a voltage decrease, sorry, I'm just going to fix my writing. So at battery or at any source. And then at the same time, the potential decreases is going to be happening at any of the load. So if it's whether it's light bulb, motors, resistor, those are when the voltage drop happens. Okay, if I were to draw a loop. So there is a circuit at the bottom right here. There is the source where the electrons are. In a circuit, the electrons will always flow from the negative terminal and coming back, okay? So if I were to do a loop, so almost imagine like an electron. Electrons will go through a battery and light bulb 1, 2, and 3 and come back. And they're telling you that in this particular case, in this loop, the total voltage gain is going to equals to the total voltage that is lost. And keep in mind, you always gain at battery and you always lost at the load. So how many battery does this electron goes through? Only one of them. And the name of the battery is TVT. So the voltage total is going to be the only gain that we have. And then how many lost would it go through? It actually would go through load 1, 2, and 3. So it's V1 adding V2 adding V3. So basically, how many loads would this go through when it goes through the loop? Sometimes pictures can be a bit more complicated. I'm just going to redraw the picture. What if I have a circuit that has some series and some parallel? Okay, so if I draw a circuit and I tell you that there is a light bulb here, and then a light bulb, and then a parallel light bulb, and then finally one more in here. So these are light bulbs, and we're going to label them. Voltage at the batteries, we use VT. Don't forget to label your battery. And I'm going to call the voltage at bulb 1. This is voltage 2, this is voltage 3, and this is voltage 4. Following the loop idea, if I have the loop, okay, and I'm actually going to make up numbers so you can see where the math goes. Okay, if I'm telling you that this VT is equals to 120 volts, okay, and I'm telling you that, I'm just making these up, V1 is 60, and V4 is, I'm going to say 30, okay, and I'm asking you what is V2 and V3? Those are the two that I don't know. So follow the rule that says Kirchhoff's law. Kirchhoff's law says that at a loop, V gain would equals to V loss. I already color coded it for you, but let's just take a look. Okay, if I am an electron and you go from the battery and you get to this point, notice at this point it actually can choose to go through the V2 or the V3. You can't go through both. Okay, so why don't we say we're going to go through the outer loop, okay, and when it comes to here, it cannot go back up to V2. It's a one-way street that takes you back to the battery. So if I follow the green line, that's a loop, and I say Okay, so V gain happens at the battery, which is VT, and is equals to, which one did it actually go through? It went through the first light bulb, so V1. It also went through the third light bulb and the fourth light bulb. If I were to do the math, so I plug in the number. VT is 120. V1 is 60. I don't know what V3 is, but I do know V4 is 30. If I do the math, 120 minus 60 minus 30, your V3 should also work out to be 30 volt. Okay, so I also found that this is 30 volt. Sometimes people would just go VT is V1 plus V2 plus V3 plus V4. You can't do that. You have to follow a one-way loop, and that's the rule. But what if I choose another path? We chose the outer ring. How about if we choose another path to go inside? What would happen? Okay, so I'm going to use another color, this turquoise blue. Okay, I'm going to go this way. But this time, how about if I go through V2 and then come back? I can't go through V2 and 3 at the same time. They have to make a choice. So if I do the turquoise, the rule stays the same. V gain equals V lost. So the gain is at the battery, which is VT. The loss happened at the load, which is 1, 2, and 4. Do you see at the turquoise blue one? I went through V1 and 2 and 4, not 3 this time. Plug in your numbers. I know VT is 120, and it equals to V1, which is 60. I don't know what V2 is, but I do know that V4 is 30. Do the math. V2 is 120 minus 60 minus 30, which is also 30 volt. Okay, take a look at these two. The V3 and the V2, and the V3 and the V2. Okay, so this is kind of the next thing that we can get it. Indirectly, we've also proven, is it fair if I say V2 and V3 are parallel to each other? So if I have something that is directly parallel to each other, I've actually have something else extra. If something is parallel, directly parallel to each other, what happened is their voltages are the same. Okay, because you either choose to go through V2 and 3 and it only dropped one, the voltage dropped one time, so they have to be the same. Okay, so let's do a little summary. Okay, and then we'll do the current law, and then we'll go from there. Okay, so we have been through the Kirchhoff voltage law. Every time when there's voltage, you look at the loop. Okay, and at the loop, V gain equals to V loss. The other thing you look for is if there's anything that are parallel to each other. If you have any two things that are parallel to each other, their voltages are the same. So these are the kind of the two things that you can pick out from the Kirchhoff's law when you study a circuit. Okay, so this is where they came from. See how all these loads, right? They're parallel to each other, and they say that all the voltages are the same. Okay? But just now, with the example I showed you, I proved to you why are the voltages the same. All right? So now let's go on to the Kirchhoff currents law. Take the time and read the rules. Kirchhoff current law. In a closed circuit, the amount of current entering a junction is equal to the current that is exiting a junction. What is a junction? Junctions are points where the electron can travel in one or more direction. So basically, a junction happens if you have something that becomes parallel and there is a split. Okay? So in here, first rule is telling you if you have any circuit that are in series, all the currents are the same. So that means in this case, the current, because the current didn't split at all, it's the same. Okay, so I'm going to add it to the chart. I didn't ask you, but I would strongly suggest you copy this chart down and have it in front of you when you're using the Kirchhoff's law, or even later on when we do the circuit analysis, it'll really help you. When I'm studying the current, okay, if I have anything that are in series, okay, so I'm just going to make this symbol. Currents are the I, voltages are the V. If I have anything that are in series, all the current would be the same. And they ask you to look for junction. The junction says the current that are going into the junction is almost like this dot, okay? It's going to equal to the currents that are flowing out of the junction. Let's take a look at this. Okay, I don't know if you remember, but I said that this is not the best way to draw the circuit. If I were to redraw this, I probably would have drawn this and split it into 1, 2, and 3. Okay, the name of the current, okay, we always call the current that is coming straight up from the battery is called IT. Okay, the IT still continues to be IT. Okay, the IT comes in and comes into this dot. That's called the junction. So this is the junction that we're talking about. Do you see the red color is going into the junction? And at the junction, what happened? It got split into 3 currents. Okay, and the name of the current, because this is called light bulb 1, this is called I1. Light bulb 2 is called I2, and light bulb 3 is called I3. And so that's why they're saying, look at that junction, look at that dot, okay? At the red dot, what is the current that is flowing in? And it has to equals to the current that's coming out. So current coming in is the red current, and the name of the red current is called IT. And what is flowing out? I have 3 things that are flowing out. It flows out into 3 streams, I1, I2, and I3. So the total that's coming out are the same at the junction. You can actually do another junction. The other junction is this green dot. This is another junction. The name of the current that's going into the junctions are actually your I1, I2, and I3. Okay, so if I were to rewrite the equation for green, the green dot right here, the I in equals I out. The in is I1 plus I2 plus I3. What's the name of the current that's coming out? Okay, from the green dot, it comes out as this one current. What's the name of this current? Let's trace back to the closest. It's still my IT. So it has to be equals to IT. So what I'm trying to show you is that it doesn't matter which one, is it the combining or the split. But it's kind of the changing from either splitting up the current or rejoining it again. All right. So please have this chart in front of you when you're doing either your homework or when you're trying out the sample problem. So let's take a look at the first sample problem. Okay, so they gave you a whole bunch of numbers. They tell you that the voltage, I'm going to highlight, the voltage at the source 1 and 3 are 40, 10, and 20. And they want you to find the voltage for 2, 4, 2, and 4. So voltage at the T, so I'm just going to write them out. So this is 40. V1, so VT is 40. V1 is 10. V2 is, I don't know. V3 is 20. And V4 is we don't know. Okay, so voltages, I look for 2 things. I look for a loop and I look for things that are parallel. So go back to this chart, right? This chart says I look for the loop. So draw a loop in your circuit. Okay, careful of your positive and minus. I'm just going to use this turquoise color again. This time my electron goes this way, right? It goes from the negative. It's going to come in. And at this point, it can choose to either go through V3 or V4. So I'm just going to make it go through V3. Just going to take the inner loop, and it's going to go through 2 and 1, and it's going to come back. So when I use the loop, this is voltage and I'm using the loop. V gain equals to V loss. Now trace the path of the turquoise. V gain happened at battery. I only have one battery and it's called VT. V lost are the loads that it went through. It went through 3 loads, not 4. 3 loads in total. Use your hand, like you can't see my hand right now, but use your hand, trace from the battery. It first of all went through V3, so that's my first drop. And then it goes back up to V2, that's my second voltage drop, and then V1. Now throw in the numbers that I know. VT is 40, V3 is 20. I don't know what V2 is, and I do know V1 is 10. Do your math, rearrange your equation. 40 minus 20 minus 10, got the voltage to be 10. Okay, so that's the first part. Now, we're not done yet, right? So go back to this chart. I am now done the loop part. The next part are, do I have anything that are in parallel? Because if I do, what happened is it's going to be the same. Okay, so let's go back to here. So the next thing that I needed to do is now look for anything that are in parallel, because if I know anything that are in parallel, all the voltages are going to be the same. The 2 parallel path is the 3 and the 4. Okay, so meaning voltage 3 would have to equals to voltage 4. And since I know voltage 3 is 20, voltage 4 is also going to have to be 20. Okay, so just be clear on, are they looking for voltage? If they are, look for the loop, look for anything that are in parallel. We're now going to move on to an example for currents now. Okay, so they're now asking you to do the current through the source is 0.4, through lamp 3 is 0.1, and they want you to find the rest. Okay, so IT, so coming right out from here, this is called IT. Okay, the current from the source is equals to 0.40 amps. And they also tell you that the currents that are going through I3, you can draw it here or here, it doesn't matter, right? Along the same path. I don't know if you remember, but anything that are in series, in the whole path, when they're the same, when there's no splitting happening, all the currents are the same. Okay, so they tell you that, I'm just going to do one time though. So they're going to tell you that I3 is equals to 0.1 amps. Okay? All right, let's take a look. Go back to your chart. I'm dealing with now the current. Okay? The first thing I would like you to find is any of the things, any of the loads or the sources, if they're in series to each other, the currents are the same. Okay, so what are in series with each other? Okay, so basically, anything that are along this path, they're in series with each other. Because then what happened here is, it's going to happen as split, it became a parallel circuit. Okay, so I'm still just going to write this down. Do I have anything that are in series? If I do, if I do, the currents are the same. So in this case, I have 3 things that are in series. IT is in series with I1 and is also in series with I2. So these are going to be the same. So that means I have found that I1 also equals to 0.4 amps and I2 also equals to 0.4 amps. Excuse my techniques, it just changes. Good so far? Okay, the next thing you do, well, let's go back to the chart again. Okay, so I'm done the series part. Anything that are in series, they're the same. I'm now going to look for the junction. Okay, whoops, don't do that. Okay, look for the junction. Find a dot. The current that's flowing in and the current that are flowing out. So let's take a look at this picture. All right, so notice this green dot I already draw. That's my junction. So I'm still going to write this out just so that we know this is what we're working on. junction, the current flowing into the junction equals to the total currents that are flowing out. What is the current that's coming in? Okay, coming in. Okay, so trace back, right? Oh, the name of the current that are going in is actually still your IT. Do you see that? Like, you basically will start off at the dot and you just go back to your first thing that you encounter. So I go back and I found that the current that is going in is IT. What are the current that are flowing out? Okay, from the dot, I go out to this guy and I go out to this guy. Do you see how I got two split? So at the dot, I have I3 and I4. So the total currents that are going in is this blue turquoise color, and the current has split into two. It's your I3 and your I4. I know IT is 0.4, I3 is 0.1. Doing the math, I4 is 0.3. Okay, so please try out the homework. It shouldn't be too bad, but I'm really asking you to make sure you do your homework because they build on top of each other. Like, if can you imagine if you don't know what a series and parallel circuit is? Can you imagine if you don't remember the term, what's voltage, what's current? It will be hard. So now we've done the Kirchhoff law, the basic law of how, two extra laws. It's almost like you're going to be dealing with like 6 equations with 6 unknown when we get to lesson 5. All these build on top of each other. They provide you with equations so that you can solve for this. Okay?